Scientific notation is a way of taking really big numbers or really small numbers and writing them more in a compact way. If you look at the example here, it says a number is written in scientific notation if it is of the form c times 10 to the nth, where c is between 1 and 10 and n is an integer. That's kind of hard to understand with the c's and the n's, but basically we're writing a number, so a number between 1 and 10 times 10 raised to another number, an integer. So it's always going to be some number between 1 and 10 times 10 raised to another number. This is really, really important when you deal with, in science, with like extremely small numbers or extremely big numbers. So let's look at some examples and how we can write things either in scientific notation or how we write them in standard form out of scientific notation. So let's look at this example here. It says rewrite in decimal form. This number right here is written in scientific notation. Now if you remember, it's going to be a number between 1 and 10, always times 10 raised to another number. 3.128 is a number between 1 and 10, times 10, notice all of these are times 10, raised to the third. Now if we want to write this in decimal form, we want to write it so it doesn't have 10 to the third. What you do is you take your 3.128 and we're multiplying it by 10 to the third. 10 to the third is like multiplying by 1,000. So move your decimal point 1, 2, 3 times. This becomes 3,128. Again, if it's a positive 3, you're moving it to the right 3 times. Like I said, it's like multiplying by 1,000. Look at part B here. 6.4 times 10 to the 4th. Take your 6.4, multiply by 10 to the 4th is like multiplying by 10,000, but you can think of it as moving your decimal point to the right 3 times. Again, like multiplying by 10,000. So it's going to become a big number, and we're going to multiply it or move the decimal point over 1, 2, 3, 4 times. Now, in this problem, kind of got a little issue here because there's nothing there. But remember, we can always add zeros in, because to put it in scientific notation, those zeros were taken out. So this is like saying 6, 4, and 3 zeros. So 6.4 times 10 to the 4th is equivalent to 64,000. Now if you look at these bottom two examples here, they're negatives. Negatives do not make the number negative. Negative exponents do not make the number negative. Let me say that one more time. Negative exponents do not make the number negative. What these negative exponents mean: if you had 10 to the negative 1 and you think of our exponent rules, that's like saying 1 over 10 to the first, 1/10, or 0.1. So when we multiply by 10 to the negative 1, we're like multiplying by 0.1. We're making this smaller. So what does that mean? You can multiply it by 0.1 or do the opposite of what we were doing over here. When we multiply by 1,000, we move it 3 to the right. We multiply it by 10 to the 4th, we move it 4 to the right. Here we multiply by 0.1 or 1/10. Move your decimal point 1 to the left. So that becomes 0.39. A negative exponent means you're dealing with a small number. 6.12 times 10 to the negative 5th. 6.12, since it's negative, okay, again, that's like multiplying by 1 over 10 to the 5th, okay, or 1 over 100,000 or 100,000th. What we can do is we can move our decimal place over 5 times to the left. 1, 2, 3, 4, 5. What do we do with those blank spots? Put in zeros. Notice I did not just add 5 zeros. I moved it over 5 places. Okay, so to make it a little neater, this becomes 0.0000612. Don't lose this 1, 2 here or anything. We're only putting in zeros for the decimal places that aren't there. Let's look at some more examples. This case, it's asking us to rewrite these numbers in scientific notation. These are already written in decimal form or standard form. What you do to write them in scientific notation, keeping in mind it's going to be a number between 1 and 10, times 10 always, raised to an integer. Find your decimal point. I don't see one, okay? So I'm going to know it's there at the end. And I'm going to move it over until I get a number between 1 and 10. I moved it over once. 5,231.4. Nope, not enough. Moved it over again. 523,000.14. Not yet. Move over again. 52.314. Not yet. One more. 5.2314. Okay, so I've now made this a number between 1 and 10. Always, 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 then you go times 10, and then you got to figure out what number do you raise it to. Well, I moved it over 1, 2, 3, 4 times, so you raise it to the fourth. Again, 5.2314 times 10,000 would be 52,314. Let's look at this example. 3.2. Find your decimal point. Now make it a number between 1 and 10. Oh wait, it already is. So in scientific notation, this just stays 3.2. It's between 1 and 10 times 10 because it's always times 10. Raised to, well, how many times did I move the decimal point? 0. Again, that one seems a little silly. Why would we write that in scientific notation? It's more just to show understanding of what scientific notation is. Look at this one here. Now this is a very small number. Again, I need to make this a number between 1 and 10. So I'm going to move my decimal place in this instance to the right. Move it over once, move it over twice. If I move it over 2 times, I get 00471. I'm sorry, 004.71. Now those 2 zeros out front don't mean anything, so I'm going to get rid of them. So now I have 4.71, guess what, times 10, raised to the, well, how many times did I move it over? 1, 2 times. Scientific notation. Except it's not just 2. 2 tells me I'd move it over 2 times to the right, like I'm multiplying by 100th. But I'm not. I'm multiplying by basically a negative 100th. So I'm going to make this a negative 2. I'm sorry, I'm not multiplying by a negative 100th. I'm multiplying by 100th. And the way we represent that is by making a negative. The way I remember it is this is a pretty big number, so I'm going to have a positive exponent. 0.0471 is a pretty small number. A number less than 1, so I'm going to use a negative exponent. Let's look at this example here. I'm going to move my decimal place over 1, 2, 3, 4, 5 times. That gives me 4.28 times 10 raised to the 1, 2, 3, 4, negative 5. Why negative? Because this is a number less than 1. Last example here. We have 602 million. If I want to make that in scientific notation, find your decimal point way here at the end, and I'm going to move it over 1, 2, 3, 4, 5, 6, 7, 8. I want to go until there's one non-zero digit in front of it. That becomes 6.02. Notice in this case I keep that 0. I'm going to get rid of all these zeros, but I'm going to keep the 0 between the 6 and 2. We need that 1 because it's a placeholder. If you get rid of that 0, you move the 2 up and this becomes 620 million instead of 602 million. It's a pretty big difference. 6.02, it's a number between 1 and 10. Write our times 10, that's what scientific notation is. And since we moved it over 1, 2, 3, 4, 5, 6, 7, 8 times, I raise it to the 8th. So writing numbers in scientific notation, positive exponents for pretty big numbers, negative exponents for those that are small. And our whole goal, remember, is to write a number between 1 and 10 times 10 raised to an integer.